This training tape will illustrate the proper procedure for installing a Chesterton 1 3/4 inch 440 seal in a typical back pull-out pump. Before beginning the tape sequence, the pump was disassembled and the power end was sent to the maintenance shop. The impeller and stuffing box were removed from the bearing bracket. The stuffing box was cleaned and the face was checked for flatness. All burrs and sharp edges were removed from the shaft sleeve. The seal installation will begin at this point. To obtain maximum life from a mechanical seal, the pump must be in good condition. Check the shaft diameter to make sure that it is within the plus or minus 0.002 tolerance shown in the instructions. A micrometer or vernier caliper may be used for this measurement. Use a dial indicator to measure the shaft runout. The total indicator reading should not exceed 1/1000th per inch of shaft diameter. Place the dial indicator on the end of the shaft and alternately push and pull the shaft in the axial direction to measure end play. If the bearings are good, end play should not exceed 5/1000ths of an inch. In this application, we are installing the 440 seal with a ceramic L-shaped stationary in a 478 gland. The stationary box contains a dimensional drawing showing several installation arrangements. A plastic centering gauge, 2 stationary gaskets, and the ceramic stationary in a protective foam pouch. The 440 box contains a warranty registration form, a hazard analysis sheet that will assist you in identifying and correcting any possible hazards that may be present, a 440 installation drawing and instruction booklet, a spare ethylene propylene O-ring, and a packet containing silicone grease and an Allen wrench. The last item is the 440 seal in its protective covering. Open the chemical listing and locate the fluid to be sealed. The listing will assist you to determine if the Viton or ethylene propylene O-ring is suitable for this service. Since no metal parts of the 440 seal contact the fluid sealed, this seal can be used in many different chemical applications. The 440 seal is also available with either a ceramic or silicon carbide rotary seal ring for use in very corrosive or abrasive applications. Puncture the grease seal packet and apply a small amount of silicone grease to the pump shaft and to the ID of the 440 O-ring. Slide the 440 seal on the shaft as far as it will go, and then remove the seal peel from the seal face. Install a stationary gasket on both sides of the ceramic L-shaped stationary and install it in the gland. The stationary may be installed nose in or nose out depending upon the application. In this application, the stationary is being installed nose in so that the nose will pilot in the 2.5-inch stuffing box bore. The stationary centering gauge cannot be used because there is insufficient space between the stuffing box face and the first obstruction for removal of the centering gauge. Install the stuffing box and bolt it to the pump bearing bracket. Slide the gland forward so that the stationary gasket is against the stuffing box face. Install the gland washers and nuts. Tighten the nuts evenly. Slide the 440 seal forward until the carbon face contacts the stationary. Tighten the socket head cap screw so that the drive ring is securely locked to the pump shaft. Cut the plastic strip that holds the 440 clips in place and remove the 440 clips. Install a new pump volute gasket. Install the impeller, and tighten it securely on the pump shaft. Check the clearance between the back of the impeller and the stuffing box with a feeler gauge to make sure that it is within specification. Rotate the shaft to make sure that there is no contact between the rotary and stationary portions of the seal except at the seal faces. The power end of the pump is now ready to be transported to the pump site where the installation will be completed.